Welcome back to Made Up of Wires, where we are decompiling Castlevania Symphony of the Night. Oh, that's not the page I usually have up. If you want to know more about the Castlevania Symphony of the Night decompilation project, go to soten.z.dev to learn more. We've been working on Doppleganger 10 and 40. I think I want to go through and try to finish the function that I started at the end of last stream, and then maybe go through and try to name things. That's one of the things that is valuable, but often gets overlooked when decompiling, as we try to get more and more of the code base decompiled. We don't often think of going back and tidying things up. So I'd like to do some of that as well. But first, let's start here, and we'll finish this up and then move on from there. There was a couple globals yesterday that likely fall into the Doppelganger entity address space. So I want to figure those out. There's this odd one here that's at an offset 77. So the single byte offset is odd, literally. But also in an address space that I'm not familiar with and was having trouble finding information about. These down here, this is all things that are going to be part of the Doppelganger address space. Everything above is going to be part of the DRA address space. And actually, I probably need to double check this address and make sure that it is actually there. I do have a wiki that I started. A lot of this is just my notes and other decompiler notes. Oh, so this 809 isn't part of DRA, it's part of main. So it's in this main address space here. So it's possible that this is something from the PlayStation SDK and not something specific to Soten itself. So we'll have to look at that as well. But the first ones I want to take care of are these up here, and we have to do some math to figure out what entity these belong to. So I'm going to get started with that. No, I'm not logged in. So to get started, I'm going to find the G. There's a couple addresses that I want to know. G entities. I want to know the Doppelganger or G entity 64. Hey, Dig Down Deep. Good to have you back. It looks like these are closest to this Doppelganger or entity 64 starting point. So that's what I think I'll start with. And I like to just line these up, and then too many Vim keys in there. An entity is size BC, so we can see how many of these are going to fall within that Doppelganger entity. So that's 73. Actually, these are not. Oh no, they are. Yeah. And I think they all are within the Doppelganger entity. Yes, yes. Okay. So then, for entities, we just need to calculate the offset for each of these, and it's pretty straightforward. So I'm going to go through and do that. Oops, excuse me. I have another game going on the side, and need to shut that down. So taking these addresses, subtracting the main starting address, and that'll give me each of the offsets. Remember not to select the D underscore. How are you doing, Dig Down Deep? Alright, each of these should be reasonably straightforward. So let's look at the entity struct and grab each one. So offset 16 is palette. And I have that elsewhere. It looks like I did figure that one out. Or no, I didn't. I screwed it up, actually. So here on 39, I said this was palette. Really, the bottom here is palette. Let's see if we can tell what's happening down here. It's this 8200. I think that I okay, so that is palette. So my offsets must be wrong. I screwed something else up. Let's look at this address quickly. See if it shows up in the build map. It does. I'm gonna do that math one more time. I don't think that I had the math wrong. Is 16, and let's see where palette is. Oh, all these are shifted. All these are shifted. So I'm off by 1 on all of these, or off by 2. But that I didn't proceed. So let's try again. So the first one is draw mode, which is an unsigned 8. The second then is rotation X and rotation Y. These should be, I think, fixed point values. So I'll update those when I'm done here. 34. Where's flags? Is it like one that I should have? And 5A is unknown 5A. Right, so then I'll get rid of all of these at the top. And where are we at? We were at 91% before. Now we're less. And that's because the symbols are now no longer matching. And so it's not terribly important. It's just the way that it is. As we get more accurate symbols, sometimes the match will go down, but that's okay. All right, so next is these others up here. We have an entity at 76394. This is going to be a different index from, and let's see if I still have this. Oh, I don't have that anymore. That was entity 65. 763C8, I think is going to be somewhere in that 65th indexed entity. That goes to 76450. So yeah, so all of these are going to be part of that, and it looks like I have all those ready. So the last one then is this 97E7, and this I'm not sure about. So I'm going to go look at the map for Maine. That's where I had this address space allocated. We can look at the splat config. VRAM aligns at 801. And so this would be 87. It's in BSS. And that BSS is not decompiled at all. So let's look at it and see if we can tell what's around that area. And whether there's anything worth anything there. So I'm looking specifically for that address, and like I said, it's a little strange. Oh, I want to get rid of that. So we're looking at 77. So we just have a bunch of word storage. So we don't know what this is, but we should have something in something in here that tells us. So splat or empty or spim, I'm not sure which tool generates this comment. We could rep around for it. Automatically generated an unreferenced pad. So that means that it doesn't think anything is referencing this data. The address space is laid out, and this is actually quite a bit of address. It's close to 1K of address space, which isn't nothing. So we have this random reference into that space that nothing else seems to know about. And let's look where it's used. We're setting it to 0, but then also never using it again. So I'm going to make a note here. Where was that? I may, I don't know if I want to really mark this as an array. It's an array with a known offset. There may be other references to 9CD44. So, is this an out of bounds array access or just using space? I'm going to make another array at D44. Subtract these, get the index, and try to access it that way and see if the same instructions get generated and the offset gets pre-computed. If that's the case, I'll leave it like that because 7D44 will have other references. The 977EE or 97EE77 will not. So it's offset 133 hex, which is 307 decimal, a nonsensical offset. So let's just see what's going on. Hey Nate, good to have you. And that does generate the same instructions. Let me do a grep for that. See if there's any other references. I'm gonna look in the build maps. So it shows up in Richter. Let's see how Richter's using it. Doesn't show up in decompiled source. So one function here, let's see. So what I'm looking for here is what symbol is Richter using? I don't see an obvious one. Let's look at that assembly and see if we can tell what. Oh, is it this one? No, it's a. So here's our call to G entities 1, and then a reference to G prim buff or G player draw. Let's go back to our. So this starts G player draw, and let's figure out how big G player draw is. It looks like G player draw may be bigger than what this is suggesting, and so this may be part of that. So good to know if that's true. We might have that definition in the context already with a size. So we know that G player draw, there's 16 of them. And we need to know what the size of each of those structs is. Size is 28. So let's 28 times. That's 280. So we're past that even. This is full of bytes, which is nice. Possibly even rectangles. If this was going to be part of that, where would it be? Let's figure that out. So we have 10 times 28. So we're going to add another 28. That gets us to 288. So that's 17, 18, 19, 20. So element 19, which is 13 hex. Oh no, I'm wrong. The 307 was binary. 307 or decimal. 133. So we are within that. 133 divided by x28 is 7. So we're in the 7th G player draw. Boy, what a pain. And then 133 minus 118 is 1B, also 1B. Enable color blend. So we figured it out. And yeah, that is, so we could add it probably is worth adding a hint in the splat config, symbols US main. These look like they're just in US. I'm going to go over here that we're G player draw 7 dot enable color blend. Just so I remember what this. This says the size is 28, but really the size is times 16. So it's 280. And so next time we extract, I could touch source, not source, config splat US main, and that should regenerate that BSS file with the location shifted down. I'll let that run. This is much slower. Oh, I'm not doing a make J though either. I'm running this virtualized now. It's the same disk, just virtualized in Windows instead of booted directly to. Much slower. All right, so here's our enable color blend. We're gonna set that equal to 0. An error on line 20 saying we're making a pointer from an integer without a cast. It's possible that I got that wrong. G player draw now does include that 97E77, so I'm happy about that. Okay, so we're loading the wrong type and restoring to the wrong type. And unknown 5C saying is a pointer. Oh, it is a pointer. Oh, so we're a pointer to another entity. So that offset doesn't make sense. Looking at it here, that also doesn't make sense. 332. I must have screwed up that math. I'm gonna shift it to unknown 5A because the type matches, and we'll see if that ends up working out. All right, so we're missing a reference to GDOP on line 35. Originally, this was written slightly differently. Let's look at where this color fill is. We're storing a word here. So originally, I think there was a sign 32 pointer. So let's do the same. We're going to grab that from GDOP out here. And then oh, this is a collider. And see how that looks. So the 0 assignment for S2 is happening somewhere else. So I think what's happening here is we're not indexing into the color floor. We're using it as a pointer, or the collider floor, not color floor. And we need to increment that then as we go. And maybe something slightly different. So here is our increment. We're not doing the right order. We have two different loads of the value F4, depending on whether this jump succeeds or not. Which is a little strange. It is possible that this is happening backwards, but I'm not sure. So V1, we need to keep track of that. What is V1 being incremented by? So V1 is being treated as a sign 32 pointer. Let's look at collider. Oh, what may be happening here? It's possible that this is a mem set. So in entity, how many colliders do we have? A lot. Where's our colliders? Come on. I know you're here. Are they in player state? Yeah, they're in player state. So collider floor, there's 4 of them. They're 24 bytes each. 24 times 4 is hex 90. We need hex F4. So let's do 24 times 8. That's 120. That's too many. So F4 divided by 24 is 6. 6 times 24 is D8. So this is an odd... I'm guessing this A0 is not what we're checking. Sign less than. That's what it looks like. Excuse me. Potential spam is calling. So what I'm going to try a mem set here and see if that will generate the expected instructions. So I'm going to set it to F4. Built-in mem set maybe. Nope, that's not what I want. Mem copy, not mem copy. What are my built-ins? Really thought that memset was one of the built-ins. Mem clear. What about bcopy? No. Stir copy? Stir copy. How about that? That needs to be real strings. One thing that is possible but unlikely is setting this to an empty array. And casting that as a collider array. No, that's not going to work because that is not how C works. I really thought memset was a built-in. Am I thinking about mem copy right? No, I'm using... Both of these are wrong. So effectively what we're doing is we're clearing this set of 4 bytes. So we do need a sign 32. We're doing this one word at a time. So we're going to need to cast this as a sign 32 pointer. It would be nice to do a size of, but I don't see how that's possible. So for I equals 0 while I is less than I mean, the best hint I have is F4. I plus plus, colliders plus plus. And then so that's mostly right. F5 in hex is 245. Like it's an odd number. Possibly there's a count outside of here. Okay, that gives the assignment outside all the time. So that looks right. That's really bizarre though. I wonder if I could take like certain fields and subtract them to get this. So they'd be compile time constants. Let's try that. So we know it starts at the PSP version is C. It's the same C as the other versions with some minor changes. Yep, they're all C. There is a possibility that the Xbox version has C++ in it. But that would just be like where it integrates with the PlayStation SDK. Otherwise, it should be the same C. So I'm gonna figure out this offset. We're trying to get to 133 hex divided by 24. That's 8, but 8 times 24 is 120 hex. So we're past the ceiling colliders. And partially into a wall collider. So I'm going to how far into a wall collider? 13 bytes. And that doesn't, oh no, I'm getting that number wrong. 24, sorry, F4 divided by 24 is 6. So we're partially through one C. We're at 1C into the 6th ceiling collider. So 048 AC 048C. So one unknown 1C. So, I mean, it's something like this, and we can see that this should work out. It's possible that this is a less than equal. That would make more sense to me. We'll cast these both as ints. That gives me 184. So it looks like my math is just wrong. So let's try that. Let's just try to go to ceiling. gives me 90. So I'm going to do this call for 0. I'll take a reference to that. Let's see. So there's 4 of them. Is 3 the magic number? No. Is 4 the magic number? That's too far. It was 3 dot unknown 1C. That's 88. Yeah, now I'm not getting a... It is still being computed at compile time, just in the wrong order. So let's try this. Try size of collider, which is 24 times 6. And this is what I was getting in my calculator. Plus 1C. So it's clearing parts of the floor and ceiling colliders. What's the difference between C and C++? C++ was originally a kind of an extension to C, or a superset of C, that added objects. So instead of just having structs, you could have an object that was polymorphic, meaning many different types could kind of adopt the same interface. The data within those objects could be protected using visibility. So encapsulation is a big hallmark of object-oriented programming. And so it started out basically as a extension to C with objects. It since has kind of morphed into its own language, and not all C is valid C++ anymore. And there's a lot of C++ that's not valid. There's different things, like the size of an empty struct in C is 0, but because there needs to be lookup tables and other things like that in C++, you can't have an object of 0 size, just for some of the metadata that's required. So yeah, they're very similar but different languages. If you know one, you don't necessarily know the other. A C programmer would have, I think, a harder time with C++ code than a C++ programmer with C code, except for C++ programmer would probably be frustrated at a bunch of the things that they consider nice not being there. So it's like a high, 50,000 foot view of the difference between the two. Okay, so there is this addition here. We have 3 things happening. That entity, the S0, and I are all being incremented. And I'm going to try sticking them all in the for loop. And then JavaScript is syntactically similar, but a different language altogether as well. And that worked. That's great. Did not expect that to work, but it did. There is 51. That value is wrong. The F0. And that F0 is coming from here. So the type of S0 appears to be wrong. Our S0 says it's an entity, and it's being incremented as an entity, but it's something else happened to offset this. Oh, are these not different? Why do we have two different variables? It's possible that this is same thing, yeah. Well, why are there two different variables? And does there need to be? Is this just the same thing? Huh, odd. So var0 can go away. That's odd. That was a hallucination by M2C. This is a strange function. All right, so one last issue with registers. So there's this shift that's missing. So when this value gets shifted by 8, my guess is that the shift is missing here. So I'm going to do that. So this is going between PlayStation and, oh, let's shift the other way. PlayStation and Soten or Konami style fixed numbers. So going from 12 fractional bits to 16 fractional bits. A little surprised that there isn't one here. It's getting generated with the multiplied by 16. So we can do that here as well. Did at one point write macros for these. I think that's right. That's it. That was it. So just shifts instead of multiplications. So I'm a little concerned that some of my offsets are wrong. Everything else seems to be working out. These guys are gone, which is great. So really, we only have these three constants, and this is a matching function, I believe. on RBO5. Let's look at duplicates report as well. So yeah, we'll just have 3 globals to match, which is pretty nice. Let's save that. Let's get some confetti. Somewhere. Oh, yeah. And what is my function called? I need to find it. Another one in the can. I'm going to do a clean build. This might take longer than normal, we'll see. Yeah, this is much slower. So, wow. So I have the computer that I do most of this decompilation on has 2 NVMEs in it, the fast one that Linux is on, and then a slower one for Windows. I wanted to play some games in Windows that run better there, and I thought, can I set up Hyper-V? Okay, undefined reference for BO4. That's not in anything that we're touching. I did a clean. Let's see what that is related to. Oh, I named this now. And didn't fix that. E7C. Why this? Oh, DUS. Missed the US. Failed. Diff boss. BO4. Okay, so we need to figure out what's going on at that particular offset. Find. And my guess is that I just got an offset wrong somewhere along the way. 41A90. 41A0. And what is wrong? So we have offset 14. 7 versus 4F. So this is going to be at 419C. Player draw. So our offset into player draw is wrong. And I have offset 4F. So the player draw. The player draw plus 1/5B. Player draw size 28. 1/5B divided by 28 is 8. And so it looks like this may be early. So we're at 4F. 7 is an odd number. So I think I'm 7 minus 4F. Oh, it's 1 off. It's 28 off. So I'm exactly 28 off. So I was just off by 1. I'm going to fix that in the scratch. I shouldn't need to copy that over. I should just be able to fix it here. And that's all it was. That's good. All right, so let's find the RB05 version. It is also in Doppleganger. It should be the top function. It is the top function. Copy that. Roger, roger. And we need these globals, but this is not going to be the name that these globals use. So we're going to have to figure out what those are next. Let's see what order they come in. These two are near the bottom. 474 is set to 0, kind of in the middle. So 474 is the one that's going to come first. Ooh, this is not a match. It's not a perfect match. So we can't just copy it over. We have to use just use it as a base for the RB05 one, but we should be able to get that pretty quick. The function signature was void void. I'm guessing that that's MTC won't have any problems figuring that out. I'm gonna just get rid of it. It looks like there's called a time attack controller that's missing from ours, or the B04 version. That might be the only difference. I'm gonna leave that time attack controller reference down there. Because I know that I'll need it back. So not quite the only difference, but effectively. So there's one other change. Our globals obviously will need to change. This is much easier to do in decomp.me than it is doing manually. So much easier that it might be worth just creating new scratches. Oh, I screwed that up. Solely drat. I need to go in a different order. These variables actually overlap. So Oh, sorry. Or did I just screw it up? Overlap? What am I doing? Oh, my copy paster is broken. Gotta get a new one. Okay, those are matching, and then there should be one more in the middle. Function names are different. Oh, interesting. Should probably map that function in VO4. I'm gonna do that while I'm thinking about it, because otherwise I will forget. Oh, what's going on? So I need to find funkus and this. And fix those references. Do this with sed as well. Doing sed inline replacements always makes me nervous, so usually I don't do that, but you could. Okay. So that is all that's needed there. I will, in the background, I'm going to re-extract and build everything just to make sure that those work again. Splat US, before. I'm going to revert all of that. So it looks like those may be different. Odd that there is. My guess is that the argument here just happens to be an A0. And that's later used, so there really shouldn't be an argument. Nope, there needs to be. Not sure what's going on there. Okay, so I'm not going to do that right now. Possibly in the future, we'll see. I will keep it the way that it is and just replace this reference. So we're missing a 01 being assigned to this 344, which is different. So instead of assigning 0, it looks like it's being assigned the value 1. So on line 41. And VRAM flag also a 1. And then that is it, I think. So let's try that and see if that works. Hopefully it was just that simple. I'm glad that I caught that early. I'm also a little surprised that the time that there is a... We'll look at the time attack function call if this works. Yep, that worked. So, time attack controller, Doppleganger 40 defeat. So this is a function that's called when Doppleganger is defeated. But this isn't where we're calling Doppleganger 10 defeat. So where does that happen in Doppleganger 10? That's happening in a function that currently is allocated to doors, or split at doors. So my guess is that Eldritch, I just saw that comment. That was excellent. Yeah, so we're calling the time attack controller at a very different time between Doppleganger 10 and 40. That's interesting. I thought those would be closer. But those are both matching now. So another function for Doppleganger 10 and 40. Is a dim sum an item? It is. Oh. So you're not joking. All right, I'm just checking what I just staged there because I staged this one really quickly. That one's fine. All right, so I think that's it for today. We got another pair of functions between 10 and 40 done. And like I said, I've been doing other things at night and not submitting any of this wonderful code. So this still hasn't made it into GitHub yet, but it should shortly. That's all the time that I have. But if you want to know more, oh, that's not what I wanted. That's not what I wanted. Oh no, this one there. If you want to know more about the Castlevania Symphony of the Night decompilation project, scroll to the top. Hey, thanks Eldritch for stopping by. Nate, thanks for coming back. Dig down deep. Always good to have you. Go to soten.z.dev to learn more. We're slogging through the remaining functions in Doppleganger 10 and 40. Let's see how many there are. $21 left in, well, I should say 21 functions. I don't know how many of them are duplicates. So it's probably slightly more between the two, but probably 30 unique functions, I would say. And those probably, they may be duplicated with reverse caverns and outer wall. We'll have to see. But that's it. Adios. Thanks for joining. Back tomorrow.